A 2.0 molar solution of styrene in ethylene dichloride is polymerized at 25 degrees centigrade using 4.0 times 10 to the negative 4 molar sulfuric acid. Calculate the initial degree of polymerization. What would be the degree of polymerization if the monomer solution contains isopropylbenzene at a concentration of 8.0 times 10 to the negative 5 molar? Use the following data as needed. Kp, the rate constant of propagation, is 7.6 liters per mole second. Ktr, m, which is the rate constant for chain transfer to monomer, is 1.2 times 10 to the negative 1 liters per mole second. Kts, which is rate constant for chain transfer to counter ion, is 4.9 times 10 to the negative 2 per second. Kt combination, which is the rate constant for termination by combination of the propagating center with the counter ion, that is 6.7 times 10 to the negative 3 per second. And Cs, which is the chain transfer constant for the chain transfer agent S, is 4.5 times 10 to the negative 2. Now, let's start by writing the formula for the initial degree of polymerization. We can get this from equation 5-38. Degree of polymerization is Kp times the monomer concentration over Kt plus Kts plus Ktr, m times the monomer concentration plus Ktrs times S, where S is the chain transfer agent. For the initial case here, there is no chain transfer agent. And then after that, we have to find out what would be the degree of polymerization if the monomer solution contained isopropylbenzene, which is the chain transfer agent. So this is the chain transfer agent S. So initially we have to first find out without the chain transfer agent, and then we find out with the chain transfer agent. So initially we can take this as 0 because the chain transfer agent is not there. So let's rewrite Xn equals Kpm over Kt plus Kts plus Ktrm times monomer concentration, where Kp equals rate constant of propagation of the chain Kt equals rate constant for termination by combination of the propagating center with the counter ion. Kts is the rate constant for spontaneous termination which involves regeneration of the initiator co-initiator complex. KTR comma m is equal to the rate constant for chain transfer to monomer. And KTR S is the rate constant for chain transfer to chain transfer agent S. In this case, it is isopropylbenzene. Okay, so now let us plug in the values because looks like all these data is given to us. So Xn equals Kp, which is 7.6 liters per mole second, times monomer concentration is 2.0 molar over Kt, which is 6.7 times 10 to the negative 3 per second, plus Kts, which is 4.9 times 10 to the negative 2 per second, plus KTRM, 1.2 times 10 to the negative 1 liters per mole second, times the monomer concentration, which is 2.0 molar, and that would be 51.4. Now for the second part, which is what would be the degree of polymerization if the monomer solution contained isopropylbenzene, which is a chain transfer agent, at a concentration of 8.0 times 10 to the negative 5 molar. So for the second part, we can use the equation 3-129, which is 1 over xn bar equals 1 over xn bar 0 plus Cs times concentration of S over concentration of N, where xn 0 is without the chain transfer agent and xn is with chain transfer agent. And Cs is the chain transfer constant for S, and S is the concentration of isopropylbenzene in this case. So let us try to plug in the values. We just found out this in the previous question. We got 51.4, so we can use that. 1 over xn bar equals 1 over 51.4 plus Cs is given to us as 4.5 times 10 to the negative 2, and concentration of S is 8.0 times 10 to the negative 5 molar, and concentration of monomer is 2.0 molar. This is again equal to 51.4, almost the same value because this quantity is very small. So your xn is also equal to 51.4.